Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 22 of chapter 4 from Engineering Mechanics Statics 9th edition by J.L. Meriam, L.J. Craig and Jen Bolton. Statement of the problem is determine the forces in each member of fluted truss. So for this truss, all member forces are required. So the method to solve is method of joints. So steps to find member forces using method of joints are listed here. The first one is select a joint with at least one known force and two or less than two unknown. So in this problem, at joint A, there is a pulley and a load L is connected by a rope with pulley. So joint A, there is one load. So this problem involves pulleys and rope system. So first I'm going to explain about the rules, how to solve problems containing pulley and cable. So for pulley and cable system, the tension in cable is equal to the attached weight. So at pulley, so the tension in cable is equal to weight attached. So that is L. So tension in the pulley is equal to L. So the tension on both sides of pulley, if the pulley is frictionless, that has same magnitude and acts along the cable. The tension on both sides of the pulley is same, which is equal to L. And then the tension is uniform along any continuous length of cable. So cable is going to start from A, passing through G, then F, and then finally is connected to H. So it is a continuous cable and tension along continuous length of cable is same. So tension on any side of the cable along that pulley A, G, and F, so that is equal to L. So I'm going to start with joint A. And at joint A, so on the pulley, the tension in the cable is equal to L and two unknown A, B, and C, D are there. So need to isolate the joint and draw free body diagram. Need to assume all unknown member forces in tension arrows away from the joint, and then need to apply equilibrium to the joint by resolving inclined member into components. Joint A is isolated, and that's a free body diagram. AB and AG are assumed in tension, and tension on both sides of pulley is same. So tension in cable, and that is equal to weight L, and then that L is making an angle 10 degree with horizontal. So L can be resolved into its component, and then AB is inclined. So its component can be calculated using triangle ABG, and in triangle ABG, its vertical side is 7 and horizontal side is 8. So using 7 and 8, so its diagonal or hypotenuse is root 113. So here is joint A. AB is resolved into component ABX and ABY, and components can be calculated using sides of the triangle. Now the L. So the tension in the rope, which is towards right, so that makes an angle 10 degrees with horizontal. So it can be resolved into its component Lx and Ly. So then there is one unknown in vertical direction. So I'm going to start with sigma Fy equal to 0. So ABy is positive. Then that tension L is negative and Ly is negative. So it is plus ABy minus Ly equal to 0. So AB comes as L minus Ly. And Ly is L sine 10 degrees. So, and then ABy using sides of the triangle. So y component is force times by y distance over diagonal or hypotenuse. So y side, vertical side is 7 and hypotenuse is root 13. So then AB times 7 over root 13. And after simplifying, AB is plus 1.7823L. So once AB is calculated, so then sigma fx is equal to 0, and for sigma fx equal to 0, AG is positive, ABX is positive, and LX is also positive. So now AG is minus ABX minus LX. Now ABX, the horizontal component of AB, is equal to horizontal side of the triangle over the diagonal. Horizontal side is 8 times by divided by root 113. So then AG is calculated as AB, which is already calculated, times by 8 over root 13 minus LX. For this side of tension, its horizontal component is L cosine 10. So now after solving, AG is minus 2.3261. So now interpretation of the signs. So interpret the sign of unknown member. A positive value indicate tension and a negative value indicate compression. So now AB is positive, it's mean that AB is in tension, and AG is negative, it's mean that AG is in compression. So AB is 1.782 L tension, and then AG is 2.3261 L in compression. So that is a solution for joint A. So after solving joint A, repeat step 1 to step 3 for adjacent joint that now have two or less unknowns. So at joint G, BG and FG are two unknown, and at joint B, BG, BF, and BC, there are three unknowns. So I'm going to start solving now G. And again at G, the tension in the cable is on the both side, and that is still equal to L. And then both sides tension makes an angle 10 degrees with horizontal. So that 10-degree angle is used to find component of tension on both sides of the pulley. Now joint G is isolated. Unknown BG and FG, they are assumed in tension. For joint G, so inclined members are L, tension in the cable on the both sides. It is being resolved into component LX and then LY, and for the other side is LX and LY. So LX is equal to L cosine 10 and Ly is L sine 10. So here there is one unknown in each x and y direction. So here I'm going to use sigma Fy equal to 0, and for sigma Fy, so Fg is positive. So plus Bg plus Ly, and Bg is equal plus 2Ly is equal to 0. So Bg is minus 2Ly. Ly is L sine theta. So Bg is minus 0.3473L. Then for sigma Fx, so Fg is positive. One Lx is positive, the other Lx is negative, and Ag is also positive. So then it is Fg plus Lx minus Lx plus 2.3261 is equal to 0. So now Lx is going to cancel with other Lx, and Fg is equal to minus 2.3261L. So now Fg is negative. So both Bg and Fg are negative. So then Bg and Lg, they are in compression. So both Bg is 0.3473L in compression, and Fg 2.3261 compression. And these are the answers for joint F. Now need to select next adjacent joint to G. So B and F are adjacent joints. At B, there are two unknowns now, and at F, there are one, two, three, four unknowns now. So I'm going to isolate joint B and going to draw its free body diagram. For joint B, AB is in tension, BG is in compression, and BC and BF are assumed in tension. So now to find component of BF, BCF triangle that is used, and to find AB, triangle ABG is used. So for joint B now, BF is resolved into component BFX and BFY. AB is resolved into component ABX and then ABY. So in vertical direction, there is one unknown. So I'm going to start with sigma Fy equal to 0. So sigma Fy is minus BFY minus ABY plus BG. So BFY is ABY minus BG. And to find vertical component using the triangles there, so force times by vertical distance of the vertical side of the triangle over hypotenuse. So then it is 7 over root 13. So BF times 7 over root 113. And then AB is 1.7823 by substituting the values there. So BF is minus 1.2550 L. Now sigma Fy(x) equal to 0. So BC is positive, BFX is positive, and ABX is negative. So BC is equal to minus BFX plus ABX. Now to find X component, it is force times by horizontal side over diagonal or hypotenuse. So horizontal side is 8. So then BF is minus 1.2550 and AB is 1.7823. So by substituting the values and after simplifying, BC is plus 2.2858 L. So now a positive value of BC is shows that BC is in tension and BF is negative, so that is in compression. So these are answers for joint B. So now the next adjacent joint is after B is C or F. So at C there are two unknowns and at F there are still three unknowns. So I'm going to solve C. So joint C, I'm going to draw its free body diagram. So that is free body diagram of joint C. So BC is in tension. So assuming CD and CF in compression. So this joint contain a zero force member, and the rule is if three members meet a joint, at joint B, three members are meeting, two are collinear, BC and CD are collinear, and there is no external load or reaction at the joint. So the non-collinear member is a zero force member. So CF is a zero force member, and two collinear member BC and CD, they carry equal in magnitude and have the same sense. So BC member force is equal to CD member force. Their magnitudes are same, and then the sense is also same. As BC is in tension, so CD must be in tension. So joint C can be analyzed using concept of zero force member. I'm going to just prove that zero force member rule is true for that joint. So now at joint C, applying sigma Fy equal to 0, so CF is equal to 0. And then applying sigma Fx equal to 0, so plus CD minus BC is equal to 0, so CD is plus 2.2858. So CD is in tension because a positive answer means that tension. So now BC and CD are equal in magnitude and they have the same sense. So joint C is solved. Otherwise, there is no need of writing equation for joint C. So joint C, the member forces can be found uh, using rule about zero force member. So now C joint is analyzed. So the next one adjacent is D or F. And F now, there are two unknown forces, and at D, there are two unknown member forces, and it is a pin sport, so there are two unknown reactions. So at D, there are altogether four unknowns. So I'm going to solve joint F now. So at joint F, DF and EF are two unknowns, so I have assumed them in tension. And then triangle DFE is used to find components of DF, and triangle BFG is used to find components of BF. So for joint F, DF is resolved into two components. Then L, tension on right side of pulley, is L, so it can be resolved into two components. And then tension on the other side of the pulley, L dash, that makes angle 45. And how is that? Because here the rope that makes an angle 45 with horizontal, so that's why I named that as L dash. Okay, so now I can apply either sigma fx equal to 0 or sigma fy equal to 0, but there is one unknown in vertical direction. So applying sigma fy equal to 0 is dfy positive. Then for this tension, its component is downward minus Ly, and for the other side of the tension, its component is also downward, so minus L dash y, and then Bf component is its Bf x is acting vertically downward, so which is minus Bfy. So now using the rule of the triangle, so the component Tfy and Bfy can be calculated. So now this equation can be rearranged that dfy is equal to plus ly plus l prime y plus bfy, and then writing them into their components and simplifying, df is plus 2.5925l, then applying sigma fx equal to 0. So for sigma fx equal to 0, dfx is positive, ef is positive, then the component of L dash is also positive, the component of this L is negative, Fg is positive, and the component of Bg, which is Bgf, that is again positive. So then whole of that equation can be written, and then taking Ef on the other side, so minus Ef, and then writing component of dfx, dfx, L dash x is L cosine 45, then substituting the value of Fg, and then Lx is minus L cos 10, and simplifying, so EF is minus 4.9439L. So now a positive DF mean that DF is in tension, and a negative EF mean that EF is in compression. So that is a solution of joint F. Now the last member force is DE, and joint E is a roller support. So as joint E is a roller support, so then I can, here the unknown is EX. EX is unknown, and then joint E, that is a three-member force. So that is a three-member joint, and it has two collinear members. So FE and EX, so they are equal, and at joint E, so there is no external load, so then DE will be equal to 0, using the rule about zero force member. So DE is equal to 0. E by inspection, DE is equal to 0. So now all member forces are calculated, and here are the answers to the problem. AB is 1.72 L in tension, AG is 2.33 L in compression, then BC, so BG is 0.34, so BG is 0.34 L in compression, then FG is 2.3261 in compression. So all answers, they matches with the answers at the back of the book. So that is a complete solution to problem 22. Thank you very much for watching.